So coming back here, this is another thing we can do is to save bitmap images. But first of all, as I used here in the analysis the color-coded image, I'm just going to show you what we can do. If we use the CTVox, also a software from Bruker, we can open here and go to the dataset where you have the dataset, the void folder, and you can notice, you can see that it has created two other folders with datasets. One is the thickness, structure thickness, and the other one is the structure separation. So we'll go for the separation. That's going to show me the pores, and I'm going to open it. Actually, I forgot one thing. I'm going to open as mark as discrete data. So these are the pores, and they are colored in based on the size, on their size, and you can see that the colors here goes. The colors go to a certain value. It's not using the whole region of 8-bit. So I will just adjust here a little bit like this. And I can play with the colors here and make the blue one to be the smallest one. So I have to grab, oops, I like to use like this. I have to grab like this. Let's try to roughly divide it into 3 parts. Just to make it fast. For the green one, I'm gonna drop everything here and oops, like this, and red one. Okay, more or less like this. So it means that the 1/3 here is representing the smallest objects. This one the medium objects, and the red one the biggest object. You can see that basically the blue ones that are representing the small ones are the pores that have been cut by the borders. And I usually don't like this kind of representation because as you can see, there are some objects that are like involved in two different colors, so it doesn't actually represent a single pore to be a single color, or like here. So but it is a good way to show how they distribute. But I can show you another way using another software where we can separate based on the volume of the pores or the size of the pores. So going back here, we can also save bitmaps that will, in this case, if I want to represent to show a 3D image of my structure, for example, I can save this image that is here. So if I go for save bitmap and I apply to the image, I can choose the format, and I'm not going to choose a folder name. It's going to be this standard IMG, and in this case it's already a monochrome image. It's a 1-bit image because it's black and white, so it's okay to choose this or not. I'm going to keep this. So this is saving the structure, and if I want to save the pores, what I can do is to come to this option here, the bitwise operation, and this one I have a lot of options here, and one of them is the not image. You can also read the documentation for this bitwise operations. So you will understand what each of these mean, what they mean. So here, if I go for the not, it means that my image is going to be transformed into the inverse of my image. So that's exactly what I want, because if I invert, I get the pores represented in white. And you see that the black part here was also inverted, but if I work with the image inside the region of interest, because the region of interest is still this one, if I work with this part here, it's going to not include the region of interest. So what I can do is now again save bitmap, and now instead of having the image, I choose for the image inside the region of interest. I will keep this as a 1-bit image and save again. It is going to save another to create another folder. I will open using CTVox again. So if I go back one step here, has created an image img. Oops, yeah, it has created img. This is, you see, the structure, and this one here is the pore. I could have selected another name, I forgot. So I will open first this one here. I don't need to mark as discrete because it's already 1-bit image. So it shows here one single color for my scaffold with the pores as empty space. If I want to include the pores here, I can go and open again, go to the folder, one click in one of the images, and I don't choose for open, I go for add. This is going to add another dataset to this one. And there you are. So it creates another color for the second dataset, and you can change the color here as you want. But now you can see the pores in red and the structure in white. You can change the opacity, for example, to make the other one disappear, or make it not so strong color. Then you see just the pores here. Of course, you can play with this as you want. You can also play individually with the transfer function editor. So this is it. Going back here, another analysis we can do is to check for the connectivity of the pores. So I can check how connected the pores are from, for example, the top of the foam to the bottom of the foam or the bottom of the scaffold. And this can be done by first separating the pores. So I can go for the bitwise operation, and either I can invert the image. If I just invert the image and I choose for example, image equals not image, it means I will invert my image. This would give me this. And since I don't want to work with this white part here, another option, I will just invert back. Another option is to go directly with the option XOR and make the image of interest XOR image. This one will make will invert my image and make it be inside the region of interest. So exactly like this. So actually it makes the image to be exactly the image inside the ROI. Now I can do the primitive ROI. This one will create a region of interest that's going to be only the last, the chosen slice. So in this case I will go for the bottom first. So the bottom and the option infimum. This one will select only the region of interest that is exactly based on exactly the object. Let's see. So this is this one. The region of interest here, actually it is only the last slice of the region of interest. And now I will go for the option ROI shrink wrap. Actually it's not only for shrink wrap, actually we have more options now here. And the adaptive in the 3D is going to make the region of interest to grow all the way from the first slice, the one that is selected there, all the way up. So this is the result. We are looking at the region of interest, and it just kept the pores that are connected throughout my image. So if you go all the way up here, you see that only this amount of pore is still remaining, and the original one was this one. It means that only the connected ones are kept all the way. You see that on the bottom here, all of them are still here, and as we go up, the ones that are not connected are disappearing. If I want to check the connectivity all the way from the top to the bottom and vice versa, I would have to apply again the primitive ROI, now starting from the top, and now it's going to select only those which are already there. And if I do again the adaptive ROI, it's going to go from the top to the bottom, and now only those that are connected are there, as you can see. Remember that this is being applied to the region of interest, and ideally I have the total amount of pores in the image. Ideally I should now invert this selection. I can go for the swap, and now I can choose to swap the region of interest with the image, just to have the region of interest to be the total amount of pores and the image to be only those connected ones. From now I can do the 3D analysis. I will not consider the additional values. I just want to see the percentage of object in relation to the total volume. And the total volume now is going to be the total amount of pores, while the object volume is going to be only the pores that are connected. I will run this. It's going to be fast, and I will check for the results. Remember that when you have the option append chosen, it is going to keep all the results from before, and it's going to append to your results on the bottom of your table the new results. So these ones here are the old ones, the first ones. So I should go all the way down, and now it begins a new task list. That's the one I began afterwards. Remember that everything is being saved here, every single step that I have done and repeated. So the 3D results were here. You can check it for the time, the date and time it was performed, and then check with your time in your clock. So this one is the important one. I can say that 69, almost 70% of the pores are connected here. I can also save these connected pores and show them separately. So I can save both the region of interest as the total connected pores, the total amount of pores, and this image here to be only the connected ones. So if I go to save bitmaps, I will choose for the image, and I will not, I can have this, but I will make another name here, like connected pores, and save. And if I save again, and now only the region of interest, there is no option for the region of interest, unfortunately. So what we can do is to copy to the clipboard that is empty. So I go to bitwise operation, choose copy, and make the clipboard to be the region of interest. It's going just to get to save in another part of the memory. It is there. So I go to save bitmaps. Now I choose for clipboard, and now I choose all pores. Let's see how it is now. If I open the 3D image, all pores, okay, I actually shouldn't have saved all pores. I should have saved only those that are connected, that are the non-connected ones. So let's do it now. We can have, for example, if I have the clipboard, if I want the clipboard to be only the non-connected ones, the ones that disappear from this image, I can use the ROI. So I can make like, for example, I can subtract, because all of them are discrete values. So if I make the clipboard to be the subtraction from region of interest, that is the one shown now, subtracted by the image, it's gonna give me just those pores that are not connected. And now I can save these as clipboard non-connected. Now it is indeed interesting to see the connected ones. Okay, these are the connected ones. And now I will add the non-connected ones. And they are shown here in red. So as you can see, somehow they are not connected throughout the sample from the top to the bottom and vice versa. This is, for example, this example here, you have a single pore that is starting from the bottom and it ends here. There is no connection when you go up. This one shows a connection here, but it stops somewhere. So this is how you can represent your connected and non-connected pores.